Reinforcing's an old-fashioned trade, so typically detail sheets were assessed in 2D, and then it was very much try and put the puzzle together when it arrived on site, and you'd usually find in that process that you were missing several pieces. We're using BIM probably for the first time in the Dunedin division to model the reinforcing wholly, so that we can try to anticipate the connections between this piling by a separate contractor, the reinforcing by one of our subcontractors, and then the forthcoming steel erection with a third subcontractor.
Having all the design consultants and the contractors in one space, being able to comment on the 3D model environment definitely builds efficiencies in the team.
So we look at it and we're like, we can't build it that way, but at the same time the architect wants something else and the services are showing us others. So using the whole BIM, we can show them, let's say, a better way.
The idea here is that we can diminish the gap between as planned and as built, so that when materials arrive on site, they match with the site conditions as built.
And right now I think it's the clash of the existing reinforcement on the ground, the reinforcement that we have to do it right now, and the future work that's going to come. So if we put that all together, we are able to catch before we see the issue. So we are able to raise it to the engineer and show we are going to have an issue on the left pit and we haven't even started.
The health and safety side of it for them is that the more that they can pre-tie or tie in a controlled environment on stands reduces the sort of manual handling aspect of it on site. So if they're only tying in lap bars and corners rather than trying to tie a whole cage in situ, is a manifestly better result for them.
So I think for health and safety in this project, we're trying to avoid working heights, and then you can see the job is really close to other buildings. So we are trying to avoid future issues, related to like precast units in general, because we have precast floor, precast panels. You've got steel coming up, 2 levels, whole frames at once. So if we can define how we're going to build it, how we're going to place, beams that are going to be up high, how we're going to prop the panels, we can actually do the work down on the ground, left it as we wanted, and it's done. I think that's been helpful. It's saving us some time, and it's saving us, in a way, saving money.